Hello, welcome to the RapidChange ATC Mach4 configuration setup. The first thing I want to point out is that if you go to Help and About, you want to make sure that your build is 5036 or later. As of April 5th, 2024, this is the latest version. If you have an earlier version, you're going to encounter problems. So make sure you have the latest version of Mach4. Now I've got everything wired up. The infrared sensors are wired and the dust cover is wired to an output. If we come up to the wizard, select wizard, and go to the input wizard, we're going to select our device. In my case it's the UC400 ETH, and we're going to look for signals. Now we should see the signal when we block the infrared sensor. And we see that the signal is triggering, and we're wired to port 1, pin 15 for the IR sensor. So make a note of that. So we'll close this out, and now we'll go to the output wizard. Now we're going to select our device again, and I've got mine set up on port 1, pin 1. Now I don't have the dust cover mounted. I like to set things up without the dust cover just in case. But I do have the arms on, so you'll be able to see them move when I toggle the output. And there we're toggling the output on port 1, pin 1. And that's operating our dust cover. So we know the dust cover pin is working, and we know that the infrared pin is signaling. So let's come over to configure. Let's disable our axes. Actually, the first thing you're going to want to do is make sure your machine is homed. So let's go ahead and home it right now. Referencing is complete. So now let's go to configure. Oh, we have to disable. And we're going to go to control. Now we're going to go to our output. Well, we'll do the input signals first. Click on the input signals tab. And under input 1, so we're going to set input 1 as the IR sensor. We're going to come over and choose our device, which in my case again is the UC400. And the input name is going to be pin 1 port 15, or I'm sorry, port 1 pin 15. It is active high, so we'll leave that alone. And we can click apply. Output signals. We're going to come down and we're going to make output 1 our dust cover output. And that was port 1, pin 1. Hit apply. OK. So now we're going to set up the wizard. Go to wizard, select wizard, scroll down until you see RapidChange ATC settings. Click OK. And this opens up the wizard. OK. So this magazine is set up along the x-axis. However, pocket 1 will be next to the tool setter. And from pocket 1 to pocket 2, we will be traveling in a negative direction. So we're going to change this to negative. Now I've got a 6-pocket magazine, but one of the pockets is being used for a tool setter. So our actual pocket count is 5. This is an ER11, so our pocket offset is going to be 38. And you can find the pocket offsets on the website. under magazine dimensions. Now we have to find pocket 1. Go to the website, info, installation, and we want to look at configure X, Y, and Z positions. If you haven't looked at this page yet, go through it and it will give you an in-depth explanation of the settings for what we're going to do in the wizard. So let's go back to Mach 4 and let's come back and pull up. Now let's go ahead and enable, because we're going to want to do some movement here. Pull the wizard back up. Now you can save without exiting. You can save and exit when you're done, but if you just save it, you can click back and forth between the wizard and Mach 4 so that you'll be able to move the spindle around. So what we have to do now is find our pocket 1 location. Come over here to jogging. Now I actually have two in the spindle, so I'm going to swap these 2 out. And we're going to call that tool 1. Let's change to machine coordinates. So we'll bring Z down so we're just inside, but not all the way down. We don't want to be so far down we can engage with the socket. So let's turn the spindle on. We'll turn it on at 2000 RPMs, which is what we're going to use for this 800 watt spindle with the ER11. Turn the spindle on, and we want to make sure that we don't hear it rubbing. I think it's rubbing just slightly on the bearings in the socket. Let's move that up a little bit. And there it stopped. Okay, but we're running free. We're not hitting the sides. But let's see if we can't fine-tune this just a little bit. I think that's probably good. Turn the spindle off. Now what we want to do is bring Z down so it is just below where the one in the pocket next to it is. That looks pretty good. So now we've found pocket 1, X, Y, and Z engage. So let's pull the wizard back up. Turn the cam off for a minute. Move this over so we can see our machine coordinates. In pocket 1, we're going to call that 286.7. Y pocket 1, we're going to call that 193, or I'm sorry, 195.43. Now, we need to set up a manual X and Y position. This is going to be the position on any type of failure. The spindle will move to this position. I like to set it over the tool setter. So since we're lined along X, we're going to be at the same position in X, 286.7. And again, make sure you're in machine coordinates. The other thing is that whatever your native units are, inches or millimeters, I'm doing this in millimeters obviously. If you were native units in inches, then you would fill this all in in inches. Now, our tool setter is positive by 38 millimeters of pocket 1. So we're going to add that 38 millimeters to the 195.43, and that will give us 233.43. Our Z and gauge, we're going to call that negative 100. Start to load. Now this is a new feature which we're implementing to minimize failure loading. Under certain conditions, the nut can get stuck at the end of the spindle and not load properly. So the way this works is that the spindle is going to come down and depress the socket slightly and then spin up, and then it's going to come back up and do a double tap to get the torque to the clamping nut. And this will help minimize the nut becoming stuck under certain conditions and not threading on to the spindle properly. So we're going to set that 3 millimeters higher than our Z and gauge position. Now the Z move to load position is going to be the height at which the spindle rises to after dropping a tool and going to load the next tool. Let me move this back over here and we'll get the screen back up. So Z move to load. As I said, Z move to load is going to be the height at which we want it to move from one tool to the next when it doesn't have a tool. So let's move Z up. And I'm just going to bring it up about there. Just want to make sure that I'm clearing any tools that might be sticking up. So we're going to call that negative 47. Z move to probe. I want that to be almost to the top, or now I've got tools that are a little bit longer than this one. I think that's about good. So we'll just call that negative 13. Our safe clearance, I'm going to leave it 0 all the way to the top of Z. For this 800 watt spindle with the ER11 nut, I'm going to load that at 2000 RPMs. I'm going to unload at 2200 RPMs. And I'm going to use a gauge feed rate of 1500 RPM or 1500 millimeters per minute. Now I've already got the probe set up, so we're going to enable tool touch off. We have the tool setter is internal to the magazine. Our tool setter is going to be 286.7. It's on the same line as the X axis, and we're going to go 233.43 since we've already found that position. Our Z seek start, I'm just going to leave it at the negative 13 that we moved to the probe or the tool setter. And maybe this should say move to measure. Z move to measure. I think I'll have James change that. So look for that. Our seek max distance is going to be the maximum distance you want the spindle to travel before it aborts. So I'm going to use about 40 millimeters. Our seek feed rate, I'm going to set at 200 for the initial seek. We're going to retreat 2 millimeters. I'm going to use a set feed rate of 50 millimeters per minute. Tool recognition, I'll enable that. The tool recognition override, if you don't have an infrared sensor or if you don't have tool recognition enabled, you'll get a pause and a pop-up message asking you to make sure that the tool has unloaded or loaded. If you feel comfortable, you can click the tool recognition override and you won't get that pause message. Now our infrared input we set to input 1. The beam is broken. When the beam is broken, it's active. So we're going to choose active there. Now we're going to find our zones for tool recognition. And what we want to do is we want to come over here, configure plugins. Maybe I can't do that right now. Alright, let me disable this. Configure plugins. We're going to go to the input states. Now we're going to enable, and we're going to bring Z down until we see, okay, we've lit pin 15, which is our infrared, and we want to be just high enough to trigger it. So let's bring it back up until we clear the beam. Okay, about negative 64.6. Let's come down just a bit, and I think we'll call that negative 66. So if I bring this back up, we're going to set zone 1 at negative 66. And what you want at zone 1 is for the nut on the spindle to block the beam. That means that when you go to try to drop the tool off, if it fails to unthread, it will rise to this zone, and if the beam is blocked, it will know that the clamping nut is still on the spindle, and it will try again. If it fails a second time to drop the clamping nut, then it will pop up a message telling you to remove the tool. Zone 2 is typically 5 millimeters above zone 1. So we're going to call that negative 61. And we're going to check that by doing a G53 move. G53 will move to a machine coordinate position. So we're going to call it Z negative 61. And that will raise Z up to negative 61 in machine coordinates, and we should see that pin go inactive. But we didn't move anywhere. Oh. G53. Here we go. And we cleared the pin. So we can close that, go back to the wizard, and now we just have to enable the dust cover. We're going to be operating this one on an axis, or I'm sorry, on an output. If you were going to operate it using an axis, you would pick the axis here. You would set the open position, which if you set up using the numbers on the website, that would be about, I think, 33 millimeter or 33 open, and closed would be 0. But we're not going to use the axes here. Now we set the output to output 1. We're going to give it a 1-second dwell. The dust cover open M code is 108. Close the dust cover 109. Save. And if we've done everything right, and I'm looking at this and I'm realizing that we have not done something right, because I just realized that it's our Y that doesn't want to change. So we want this to be the same. What we needed to change here and here was to add 38 millimeters, which gives us 324.7. So we'll enter that there. 324.7 there. And now I believe we are all set. Save and exit. Now we have tool 1 in the spindle, but Mach4 thinks that we don't have a tool in the spindle. So we're going to change that to tool 1. and we're going to type in M6T0, and if we're lucky, we will drop the tool off. Did we not change to tool 1? There we go. I must have forgot to hit enter. You can see the dust cover arms opened. And we successfully dropped the tool. Now let's go ahead and pick tool 1 back up. Okay, now we've picked up tool 1, we've measured it, and you'll notice that we're G43 down here, and you can notice here it set the height to tool 1. So the way this works is we're actually updating the tool library with the offset every time a tool is loaded and measured. Now I want to move to X0, Y0 in work coordinates. And I don't have a tool touch off plate, so I'm going to use a 1, 2, 3 block to gauge our height. Turn that up a little bit. And there we're basically 76.2 inches. So we're going to come over here and we're going to call 0 76.2. Now we're going to change to tool 2. M6T2. Cycle start. Open the dust cover. Drop off tool 1. Go back to our measuring position, X0, Y0. Z 76.2. Grab our 1, 2, 3 block, and we're right there. Now I'm going to show you what happens when that signal is blocked if it fails to drop a tool. So I'm going to go ahead and block the signal, and you'll see that it tries again. And I unblocked the signal so it didn't throw the error. Likewise, when picking up the tool, Okay? Message pops up. Can't see it. Tool 1 failed. Zone 2 recognition. So you're going to manually, if we had not picked the tool up or had it been faulty, we would take care of it manually, get it loaded, and then press OK. Goes on to measure it. Check it. We're right there. And it looks like we're good to go.